And welcome to another video from Algebra. Today we're going to be covering the associativity implies total associativity theorem. Now, what's the claim? Well, the claim is very general indeed. So, suppose asterisk is some associative operation on some set X. And moreover, let us have let the elements A1, A2, A3, etc. up to AN be elements of the set X. Then the value of A1 dot A2 or asterisk A2 asterisk A3 asterisk etc. up to asterisk AN is invariant under the change of, let's say, bracketing or brackets. Alright, how do we prove this? Well, proof. We shall proceed by induction on n. If n is equal to 1 or 2, there is nothing to prove. Right. So we're going to have to start from the case n is equal to 3. But if n is equal to 3, then the claim is identical with the associativity or associative property of asterisk and therefore holds. Right. So we have established our base case. Thus, we have established our base case. All right. How do we proceed from here? Well, we shall define our induction theorem, or induction hypothesis. So, induction hypothesis. Now, assume that the claim holds for all elements. Let's say that assume that the claim holds for all such expressions if n of length smaller than n. Right, this will be better. Okay, well, what now? Well, our next approach is obvious and it's quite trivial. So what we do is we take two bracketings of the given expression. Alright, so we have two such bracketings. So we have A1 dot A2 dot etc. up to here I denote the asterisk simply by a dot, up to some AI dot, and now AI plus 1 up to AN, and the second bracketing will be A1 A2 up to some AJ dot, then we have AJ plus 1 dot up to AN. So we have two different bracketings, and we shall show that they are equal, and this will conclude the induction step, and thus prove the induction hypothesis. Thus prove the claim. We shall need the induction hypothesis and the associativity for three elements, right? So we take the first one, say this one, right? So we copy this, and we get that this is actually equal to, well, now we use the induction hypothesis. So we copy the first bracket, A1, A2, up to AI, and then we break up the second one, so times, and now we break it up, so we have AI plus 1 up to AJ dot, then we have AJ plus 1 up to AN, right? We have essentially three, yes, we have essentially three entities here, here, and here, and we know that for three elements, associativity works, so we can change the brackets. So say we can change it to be this. So AJ times, and now AJ plus 1. But this, of course, is nothing else than the other bracketing. So this is equal to AI times A2, etc. Up to AJ. So we combine these times AJ plus 1 and so forth up to A. To do this, by the way, to change this and unite it here, we have also used the induction hypothesis, right? And this concludes this easy exercise-like proof.